So let's look at one of the biggest problems in classical networks which you have studied till now, that is multi-layer perceptrons or convolutional neural networks. Both are example of a kind of network which are called as feed-forward networks. So feed-forward networks are basically those neural networks where the direction of flow of information is always from the source, which is input, all the way to the output layer. So it's a one-directional input flow. It's a one-directional flow of information. It's a one-directional compute the way it goes on. Of course, during backpropagation, you come back and update the weights, but the way it looks at is the direction of weights is from input layer to the first hidden layer, then first hidden layer to the second hidden layer, then second hidden layer to the third hidden layer, and the third all the way on going to the output layer. Now, one of the biggest problems in all these architectures which are feed-forward networks is that if a use case or an example application of the machine learning requires us to model dependence upon a past point in the same data. So I'll motivate you with a simple example. Let us say I'm telling a natural narrative of speech. I will say, it has been tough managing, the cat I have at my home. It sheds a lot of hair. If I say it means it is referring to the cat which I have described in the previous sentence. And let me tell you, there will be several examples, especially in what we call as sequential data, like the set of flowing text, which I have given example of. Or let us take an example of, suppose I want to forecast the weather in terms of extrapolating the temperatures over the past few hours. Or let us say I want to project the stock market opening price of a stock based on how the previous few days of the stock has been. Or let us take the example of, instead of speech, let us say we have a text where, suppose I have a set of flowing text which is very similar to what I have in my speech, which I gave example. I should be able to decipher the next word in my text, or probably all of you are aware of the smart keyboards where as you're typing, you will see that there is always this, updated forecast of what is the future character or word you're going to predict. Or if you've seen Google Instant, it's a classic example of where if you're typing something, you try to predict what keywords you're searching for. So in all of this, there is a dependence of the future in terms of the past point in the same data. And unfortunately, all the feed-forward networks, which are like multi-layer perceptron or the conventional neural networks or convolutional neural networks, which are all feed-forward networks, they do not have this power of memory, which is basically remembering something done in the same data point in the past to be able to decipher something in the future or the future point. So that is a big motivation why we cannot remain in the realm of only feed-forward networks and have to resort to what we call as more general architectural networks, which is what we call as recurrent neural networks, which will be the basis of today's lecture.